Hello friends, now today we discuss the next lecture. So I can say this portion of electrical potential, we have started this journey from first part. After that, from first part to we can say to the completion of part 11b. So we have discussed all topics associated with electrical potential. If you analyze this chapter number 2, then what is the heading? Chapter 2, Electrical Potential and Capacitance or Capacitor. So this is, I can say, the last theoretical lecture of this electrical potential. From the next session, we will start, that means from 13, this is 12a or 12b. In 12a, we will discuss theoretical portion, last theoretical portion. 12b, we will discuss very important some logical points about JW need, about electrical potential. And then from 13 part, we will start most IMP point, capacitor and capacitance. So friends, this is also very IMP for the next coming part, that is capacitor and capacitance. So today, we will discuss the most important point. This is the last theoretical portion of electrical potential, but part 12 or 12a, you can see 12a. Ready? So what happened here? This entire discussion based on some fundamental concept. There is no mathematics. Most of you can see that theoretical discussion, so be alert. Today we will discuss the behavior of a conductor in electric field, or I can say that electrostatic of a conductor. Electrostatic of conductor, or I can say behavior of conductor in electric field. So we would like to think about 5 properties, or 5 we can say the important points about the behavior of any conducting material or metallic material placed in electric field. So this concentration required turn by turn. This is the most time the theory है, 2 marks भी पूछ सकते हैं. Give behavior, or I can say that important points about the, we can say that, or important characteristics of conductor whenever it is placed in electric field. So we start with the first one. So you can see, suppose this type of conducting material is placed between these 2 plates. These are the 2 plates. This is positively charged plate, while this one is the negatively charged plate. Between these 2 plates, obviously charged plate, so electric field is produced. This is the direction of electric field. You know that very well. Electric field is always from positive plates towards the negative plate, or from positive charge towards the negative charge. This is called external electric field. Okay, now this is your metallic material. You know that metal, what are the constituent particles of metal? ये अपन लोग स्टैंडर्ड 11 से चिल्ला के डिस्कस करते आ रहे हैं. मोस्ट टाइम पे constituent particles of metal, you know that free electrons, and number 2 positive ions. Free electrons always in, we can say that, free form, while positive ions are heavy in bound state, and they are situated at fixed point. These fixed points are called lattice point, you know that very well. So here are lots of free electrons, but these electrons already inside the electric field. What happened? Any charged particle is inside or placed inside the electric field, then what happened? Obviously it experiences some force. What's the formula of the force? You know that force F is equal to QE. This is the formula of this force. And here, whatever the electrons are present, these electrons also experience some force due to this applied external electric field. But you know that we are discussing for electrons. For negatively charged particles, this direction of force always in opposite direction of electric field. So here electric field positive to negative. So whatever the force acting, or I can say electrical force acting on these electrons, free electrons of the conductor, this force in opposite direction. So force acting in this direction. This is force. Because of this force, all electrons are accumulated here. You can see, and that's why here positive charges already you can see that open, because you know that very well. Here by losing electrons, this portion becomes positively charged. So here negative charges accumulation, or here accumulation of positive charges. Initially, number of positive and negative charges we can say that in less amount, but with the passage of time, continuously, force acting continuously, more and more number of electrons get transferred here, more and more number of positive charges open. So here continuously the intensity of electric field inside the conductor, where IMP, because of this charge is positive negative, one more electric field is produced, but it is inside the conductor. What is the direction of this electric field? Obviously it is positive to negative. Electric field always from positive to negative. This is called internal electric field. So now you can see there are two fields. Number one, external electric field, and number two, electric field inside the conductor. It is called internal electric field. Initially external electric field is more than that of internal electric field, but after some time, whenever enough, we can say that amount of charge is present, then both electric fields becomes equal. Whenever external electric field and internal electric field becomes equal, then obviously they cancel the effect of each other. So what is the resultant electric field? If they both cancel the effect of each other, then inside the conductor resultant electric field becomes zero, and this charge is distributed, you can see that, over the surface. Ready? So this is the first most IMP, we can say that characteristic whenever any conducting or metallic material is placed inside the electric field. Number one, what is the most IMP? The net electric field. The net electric field inside the conducting material always equal to zero. Don't forget. And whatever the charges, you can see that these charges distribution take place, just we can say that over the surface of this material. Here I have considered negative, you can also consider positive, no problem. So positive charges you can see, positive charges also we can consider. In short, charge is distributed over the surface, while inside the field, inside the conducting material, electric field always zero. You can also check by considering some mathematical logic. For example, if you consider this type of Gaussian surface, you can see I have considered a Gaussian surface very close to the surface of this conducting material, inside the material but very close. Now I apply Gauss theorem. So as per, you know that Gauss theorem. What is Gauss theorem? It is E dot ds is equal to sigma q upon epsilon naught. What is the E dot ds? But here E is 0. So obviously q by epsilon naught is equal to 0. So it implies that q is equal to 0. So what is the net charge inside it? 0. No charge, obviously no electric field. So most important point. Second number characteristic. Electric field inside, net electric field inside the conducting material 0. Whenever it is placed in electric field. And number 2, net charge inside the material also 0. So these are the 1 and 2. These are the two characteristics we have discussed. Number 1, any conductor or metallic material placed inside the electric field, then first point, the net electric field inside the conductor 0. Net charge inside the conductor 0. Whatever the charge is distributed, it is only on the surface of the, we can say that, only on the surface of the body. Okay, sorry for disturbance, but now we move towards the third number. So third number also very interesting, because of this positive charge or whatever the charge distributed over the surface of the body. Tell me the direction of electric field because of this charge. If you consider positive charge, then electric field outward. If you consider negative charge, electric field inward. But whatever the charge you consider, either positive or negative, but whatever the electric field is produced due to these charges, it is always perpendicular to this surface. Suppose at this point P, at this point R, at this point S, intensity of electric field always perpendicular, or I can say that perpendicular to, we can say the given point, or locally perpendicular, you can see. So most time in number 3. First of all, net electric field is 0. Number 2, net charge is 0. And number 3, electric field just outside of the conductor, electric field always perpendicular to the given point or perpendicular to the given surface. Most time in number 3. Number 4, you are already aware about it. Number 4, what is the intensity of electric field inside the material? 0. So what happened with the potential? Anybody? What is the potential inside this conducting material if electric field is 0? Few students have already given answer, I can say. And you know that because of this very IMP formula, E is equal to dV by dr. Here E 0, so V always remain constant. You know that. Fourth number, anytime whenever any conducting material is placed inside the electric field, then what happens? Inside it, electric field 0, electric charge 0, electric field always perpendicular to surface, and number 4, potential remains constant. Inside this material, potential remains constant. Very IMP. 2006 में पेपर में क्वेश्चन एमसीक्यू में था मोस्ट टाइम पे इलेक्ट्रिक फील्ड 0 inside the conductor, what happen with the potential? Obviously if any conducting material is placed inside the electric field, then always potential remains constant inside the conductor. तो ये जो चार पॉइंट्स है बहुत ही इजी थे और बहुत ही आई कैन से दैट इजीली अवेलेबल है, इसके बारे में इतना कोई ज़्यादा डिस्कशन नहीं है, फिर भी हमने काफ़ी कुछ डिस्कस किया, फिर भी अपन लोग वापस चार पॉइंट्स रिवाइज करते हैं. What is the behavior? What are the characteristics of what are the characteristics of conductor or metallic material whenever it is placed in electric field? So these points are called points about the electrostatic of conductor. Number 1, the net electric field inside the material 0, net charge inside the material 0, electric field at any point on the surface always perpendicular to the surface, and number 4, potential inside the conducting material or metallic material remains constant. Most IMP. Now we'll discuss the fifth number. Fifth number I can say 2 marks theory. Okay, पूछने के chances ठीक ठाक, मगर फिर भी इसको अवॉइड किया नहीं जा सकता है. सो फिफ्थ नंबर वेरी IMP. इसको अपन लोग ऐसा भी कह सकते हैं कि इंटेंसिटी ऑफ इलेक्ट्रिक फील्ड ऑन एनी चार्ज्ड बॉडी, ओके, ऑलवेज डायरेक्टली प्रोपोर्शनल टू सरफेस चार्ज डेंसिटी. और आपको ऐसा भी क्वेश्चन पूछ सकते हैं, ऑब्टेन द फॉर्मूला फॉर इलेक्ट्रिक फील्ड at any point of charged conductor. So suppose this type of conducting material is already placed. You know that very well, any conducting material placed inside the electric field, then because of this effect of electric field, charge is distributed along the surface or over the surface of the, we can say that body, a metallic body के ऊपर charges ऐसे आ जाए. And you know that because of this charge, whatever the electric field is produced, it is perpendicular to the given surface. Ready? Now I would like to find the formula of this electric field. Obviously, to find the formula for electric field, we will consider a very small, I can say small size cylinder, tiny cylinder, and this small size cylinder is also called pillbox. And at present time, I have considered a pillbox as a Gaussian, you know that very well, as a Gaussian surface. Ready? So this is your Gaussian surface, and let the area of cross section here already S. Whatever the pillbox we have considered, what's the, we can say that area of cross section, it is S, and this is the direction of electric field, you know that very well. Now I would like to represent this S or area vector in the form of area. Then you know that very well what is the direction of it. It is already perpendicular to the surface. In short, E and S both are in same direction. You can also consider delta S. ये हम लोग जानते हैं because of Gauss theorem. So start as per Gauss theorem. What is the Gauss theorem? You know that E dot ds or E dot S. E dot ds is equal to sigma q upon epsilon naught. Ready? Now we'll move towards the next point. Here E dot ds. If you think about E dot ds, first of all we will find E dot ds. So E dot ds is equal to E ds. You know that very well. If you remove dot product, so E ds cos theta. But here E and ds, E and delta S both are in same direction. So E ds cos 0, cos 0 1, and E remains constant. So E ds, and what is the integration of ds? S. S is the area of this considered, we can say the pillbox, it is S. So अपन लोग direct S लिख सकते हैं. So this is your E dot ds. Now sigma q. How can you find sigma q? Sigma q, that means surface charge density का concept. You know that suppose sigma is the surface charge density. So what's the formula of sigma? Sigma is equal to charge upon area. So it implies that charge is equal to sigma A. You can see that Q is equal to sigma A. Use this value here in this equation number 1. E dot ds. It is already with you. So I will write from equation number 1. Here E dot ds, it is E into S is equal to sigma Q. It is already sigma into area, but here area already S. So sigma into S upon epsilon naught. S cancel. So what is the electric field? It is sigma upon epsilon naught. This is the most scientific formula. This is the formula of electric field at any point along, we can say that, or whenever charged, this is the formula of electric field at any point of the charged body. Whenever any conducting material placed in electric field, then what are the charge distributed because of this charge? This is the formula of electric field. So ये भी पूछने के chances है, but this is your, you can see the fifth number. Electric field at any point along this charged conductor is always directly proportional to the surface charge density. This is very interesting point, sigma upon epsilon naught. तो ये पूछे तो भी बहुत easy है, बहुत ठीक ठाक चांस, क्योंकि इस चैप्टर में बहुत सारी थियरी बेस्ट ऑफ द बेस्ट पढ़ी, मगर फिर भी इसको स्टैंडर्ड स्टूडेंट्स तो एक बार अच्छी तरह देख ही ले ताकि वो कोई रिस्क ना ले सके. So this is your fifth number. Once again I will revise 4 to 5 characteristics. Number 1, what happens if any conductor or metallic material is placed inside the electric field? Number 1, net electric field inside the conductor 0. Net charge inside the conductor 0. Number 3, electric field at any point along the surface of conductor always perpendicular to surface, perpendicular or normal to surface. Number 4, potential, electric potential inside the conductor remains constant, very IMP. And fifth number, intensity of electric field along this surface of, you can see that conductor or over the surface of conductor always directly proportional to the surface charge density, or in other words, the formula of electric field at any point along the charge of the conductor or at any point along the, we can say that conductor is given by equation sigma upon epsilon naught. So these are the 5 most common points. Sometimes they provide, not we can say that the completely solid conductor. Sometimes they provide, we can say that conductor with cavity. Then what happens? So we discuss the next point. This is, you can see that informative type, knowledge related. So just concentration required. Okay, important formula एक ही पूछ सकते हैं, ये याद रखना. Number next, you can see, suppose this type of body is given, but there is a cavity inside it. Cavity, you can see there is a gap. And what happens if this type of conductor with cavity is placed inside the electric field? Whenever conductor with cavity is placed inside the conductor, then obviously the same story. The charge is distributed only along the surface, and that means whatever the free charge distributed along the surface, and inside the body, what happens? Electric field becomes 0. Inside the conductor also electric field 0, most IMP. So inside the cavity, what happens? The electric field, it is always 0. So this is the, we can say, the most IMP point. Anytime a conductor with cavity is placed in electric field, then what is the intensity of electric field inside the cavity? It is always equal to 0, and this entire phenomenon is called electrostatic shielding. ये most time की word है electrostatic shielding. Shielding, protection layer, you know that shielded, you know that shielded, and then shielding. So electrostatic shielding, तो ये जो shielding का point है वो अपने को कहाँ किस तरह काम में आ सकता है? So we discuss. So very interesting point. Once again, a conductor with cavity inside the electric field, then always what is the electric field inside the cavity? Always electric field cavity 0. And this entire phenomenon is called electrostatic shielding. What happens and where we can consider electrostatic shielding? For example, some application. If you are, we can say that going from one place to other, why we can say that your car. And this is the season of, suppose you can see the thunderstorm in monsoon, so in thunderstorm, obviously there is, we can say, the chances of lightning. In this situation, most of time, some very smart, I can say not smart but very over smart, कुछ बंदे बहुत ही over smart होते हैं, smartness तक very good, मगर बहुत स्मार्टनेस से भी कुछ लोग बहुत ज्यादा ऊपर चले जाते हैं, जो उसको अपन लोग ओवर स्मार्ट कहते हैं। वो सपोज कार थ्रू जाते हो और इस तरह का, जिसे कह सकते हो, मौसम हो, बिजलियां चमकती हो, जबरदस्त बारिश होती हो, ऐसी सिचुएशन में कुछ लोग बहुत ज्यादा लॉजिक अप्लाई करते हैं, होता नहीं मगर फिर भी अप्लाई करते हैं। उसको ऐसा लगता है कि ये कार पे बिजली गिरेगी तो अपन लोग है और लुढ़क जाएंगे, तो इसलिए वो कार को साइड में रखते हैं, ये सीधे जिसे कह सकते हैं कि कोई पेड़ के नीचे खड़े रह जाते हैं, और जब जैसे ही खड़े रहते हैं तभी वहां पे बिजली जिसे कह सकते हैं कि उसके ऊपर गिरती है। तो कहने का मतलब है कि आप ऐसी सिचुएशन में कार में जाओ, क्योंकि ये आपकी कार है, ये पूरा जिसे कह सकते हैं आप, जिसे कि मेटेलिक शील्ड है, बोनेट अपन लोग कहते हैं, जो ऊपर का लेयर है वो मेटेलिक पूरी बॉडी, और कार की विंडोज, ऑब्वियसली डोर्स तो बंद ही होंगे मगर विंडोज सब बंद करके केविटी जनरेट करते हैं, ऐसी केविटी। ओके, अब आपके ऊपर इसके ऊपर बिजली गिरेगी तो भी जो भी चार्ज है वो बोनेट और मेटेलिक बॉडी पे डिस्ट्रीब्यूट हो जाएगा, आपके ऊपर कुछ इफेक्ट नहीं आएगी, क्योंकि आप केविटी के अंदर, और केविटी के अंदर इलेक्ट्रिक फील्ड कितना होता है, 0, सो देयर इज नो प्रॉब्लम एट ऑल, और आप अपने आप को बचा सकते हो, कुछ प्रॉब्लम नहीं होगा। दिस इज कॉल्ड इलेक्ट्रोस्टैटिक शील्डिंग। सपोज फ्यूचर में आप कोई बड़ी कंपनीज में जाओ, उसमें कुछ डेलिकेट इंस्ट्रूमेंट्स, डेलिकेट डिवाइसेस के साथ आपको काम करना पड़ता है, और वो डेलिकेट डिवाइसेस इसलिए डेलिकेट मैं बोल रहा हूँ, बहुत महंगे भी होते हैं, प्रीशियस होते हैं, उसके ऊपर फील्ड इफेक्ट, फॉर एग्जांपल मैग्नेटिक फील्ड, इलेक्ट्रिक फील्ड, इलेक्ट्रोमैग्नेटिक फील्ड, ऐसे फील्ड की इफेक्ट आए तो वो डैमेज हो सकते हैं या फिर उसका कैलिब्रेशन चेंज हो सकता है। सो टू सेव, टू प्रोटेक्ट दिस टाइप ऑफ वेरी डेलिकेट डिवाइसेस और इंस्ट्रूमेंट्स, ओके, from the effect of electric fields or magnetic fields, especially electric field here, then we have to think about this type of cavity or electrostatic shielding. This type of devices are kept inside the cavity because there is no electric field, there is no any type of problem to, we can say that, this type of very precious devices. तो ये भी बहुत बड़ा, जिसे कह सकते हैं, बहुत ही इंपॉर्टेंट एप्लीकेशन बन सकता है। तो ये सब जिसे कह सकते हैं कि इलेक्ट्रोस्टैटिक शील्डिंग रिलेटेड पॉइंट्स हैं। तो फ्रेंड्स, जो हमने डिस्कशन किया, ये पूरा आज का जो ये पोर्शन था, वो एक पोर्शन बाकी था, इलेक्ट्रोस्टैटिक शील्डिंग और बिहेवियर ऑफ कंडक्टर इन इलेक्ट्रिक फील्ड, और इन अदर वर्ड्स आई कैन से दैट इलेक्ट्रोस्टैटिक ऑफ कंडक्टर्स। तो ये जो पोर्शन, उसमें 2 ही क्वेश्चन पूछ सकते हैं, और वो 2 क्वेश्चन का सबसे अहम क्वेश्चन है, गिव कैरेक्टरिस्टिक ऑफ कंडक्टर इन electric field or placed in electric field. So once again I revise the 5 punching points. Number 1, first, whenever any conductor or metallic material is placed inside the electric field, then what happens? Number 1, net electric field inside the conducting material 0. Net charge inside the conducting material 0. No charge, no electric field. Electric field at any point along the surface of conductor is always perpendicular to given surface or perpendicular to surface. Number 4, very empty. Number 4, inside the conductor, electric field 0, no doubt, but electric potential remains constant thoroughly. And number 5, the intensity of electric field at any point along this type of surface of conductor is given by equation sigma upon epsilon naught. It can be easily obtained by using formula of Gaussian theorem or by considering pillbox type of Gaussian surface. And the 6th number we have discussed, it is electrostatic shielding. If any conductor with cavity is placed inside the electric field, then what is the intensity of electric field inside the cavity? It is always 0, and this effect is called, or this phenomenon is called electrostatic shielding. And we have discussed already few points about the application of electrostatic shielding. तो सभी points है, इसके related कुछ बेहतरीन conceptual points है JEE NEET, जो अपन लोग न्यूमेरिकल सेक्शन और JEE NEET में देखेंगे। अभी मैंने इसमें टेक्स्ट बुक ओरिएंटेड वर्क किया है, क्योंकि ये जो पोर्शन है उसके ऐसे देखा जाए तो मायने है, कुछ थियोरेटिकली ही ज्यादा है, न्यूमेरिकली 1-2 जगह पे काम में आने वाला है। तो थियोरेटिकली 1-2 थियरीज की जो डिस्कस की, और लॉजिकली अगर देखा जाए यानी JEE NEET वाइज, तो अपन लोग जब वो सेक्शन आएगा तब इसमें और डिटेल स्टडी करेंगे। अगर टेक्स्ट बुक में इतना ही है, और इसके रिलेटेड फ्यूचर में न्यूमेरिकल्स टेक्स्ट बुक की बहुत ज्यादा कुछ है नहीं। So this is the last topic of electric potential. अब अच्छी तरह सुनो, तो ये इलेक्ट्रिक पोटेंशियल की जर्नी हमने पहले से शुरू की, ये इसका लास्ट थ्योरेटिकल पोर्शन था। अब इसके बाद जो गेम शुरू होने वाली है मोस्ट आईएमपी कैपेसिटर एंड कैपेसिटेंस। और आप देखोगे फ्यूचर में कि कोई ऐसा पेपर नहीं होगा जिसमें कैपेसिटर कैपेसिटेंस रिलेटेड क्वेश्चंस ज्यादातर ना। तो बहुत ही बेहतरीन टॉपिक शुरू होने वाले हैं फ्रॉम वी कैन से द नेक्स्ट। और अपन लोग जानते हैं कि अपना शेड्यूल किस तरह है। हम इसे कह सकते हैं कि 5 लेक्चर्स है, ट्यूसडे वेडनेसडे थर्सडे फ्राइडे सैटरडे, वो ज़्यादातर जिसे कह सकते हैं थ्योरेटिकल रीजन में रहते हैं। और संडे का जो लेक्चर होता है वो जेडब्ल्यू नीट, तो ये संडे भी अपन लोग जेडब्ल्यू नीट का पेपर। इसके बाद का जो पार्ट है 12B, वो हम लोग देखने वाले हैं वेरी इंपॉर्टेंट जेडब्ल्यू नीट रिलेटेड न्यूमेरिकल्स और सम वेरी इंपॉर्टेंट एमसीक्यूज बेस्ड ऑन इलेक्ट्रिक पोटेंशियल। सो फ्रेंड्स, revise these whole points, you know that, and on website now I will provide the most key theories list, so you have to start the preparation, think about all numericals associated with electric potential. So next time we'll meet with, we can say, the 12B, but for JEE NEET. Thanks.